Recording now. Okay, so we're going to work on homework number 1. It's also labeled number 6 in the worksheet. It's a U substitution problem, and it goes. So let's say this is homework number 1. Also, it's called number 6, a U sub, and problem number 11. And it goes to integral of x e to the x squared dx. So I see this problem. It looks ugly. I don't know the integral of x e to the x squared, and I feel what you're feeling. I'm getting sweaty. I have no clue what's going on. It's like a bad date. But we do know this. Let's go back to our basics. We know the integral of e to the x dx, e dx plus c. We know that. Okay. We know that the integral of e to the x is e to the x. Same thing. The derivative of e to the x is e to the x. So we take a sacrifice. If I can make that into just x, or let's write this in a u, e to the u du, it's just a variable, we can win. So we take our sacrifice. U is equal to x squared. Du is equal to 2x dx. Like, don't even stop. Once you take the derivative, just keep going. The more you practice this, the faster you'll be. And if we take a look, this x here divides out with this x. We're going to clean it up. It's a 2 for 1. Integral x e to the u. Let's solve for dx. I need to write dx, right? Dx becomes du over 2x equals to dx, right? That's what happens when I solve for that. So dx is replaced with du over 2x. Something kind of nice. X and x, those clear out. And if you notice, we only have one type of variable left. Not x's, not a mix of x's and u's, just e to the u du. And we're going to move our, my writing's terrible, e to the u du, and we're going to move our 2 on the denominator as a fraction to the outside, just to make my life easier. That's my identity. Rewriting it, the integral of e to u is just e to the u plus c. You could write this as that, right? Because this is that. And you can write that 100%. It's 1/2 e to the u plus c over 2. But isn't c over 2 just some constant? So we just write instead plus c.
Excuse me, where did you get the 1/2?
1/2? 1/2 was from this value right here.
I see.
Okay. And we always have to go back and replug it back in, what u is. So it's 1/2 e to the u, back here, right? That's u, is x squared plus c.
Where did du go?
Where did du? Okay, so number 14. 14 on homework number 3 is the integral of cosine 2x sine to the 4th of 2x dx. Okay. Is this an identity that we know, sine cosine? Not that I can recall. Not on my cheat sheet. We'll try U substitution. Would I want to sacrifice sine or cosine? Cosine looks more complicated, so we're going to use him as a sacrifice. And usually, it's the one that looks like it's inside the chain rule. So let's go ahead and start. If u was sine of 2x, then du would be cosine 2x, chain rule, times 2 dx. And this cosine would divide out with that cosine. What if I chose the wrong one? Let's use a different font here. What if I said sine to the 4th of 2x? What if that was my u value? Du is equal to 4 sine cubed of 2x dx. Oops, I forgot something. Chain rule times cosine of 2x, then times 2 dx. There's way too much stuff going on. I just wanted to get rid of cosine. There's too much stuff. So I picked the wrong u, which is fine, as long as we recognize that. Am I here? The integral of cosine of 2x u to the 4th power. We're going to switch du to become, sorry, dx is going to become du divided by 2 cosine of 2x. All right, I'm going to take that, put it on the denominator. Du over 2 cosine 2x. Lucky for me, which we're planning, that gets rid of all the functions with x, all the values with x's. And then we have a integral u to the 4th du, but we still have this 2 on the denominator. That's a constant that goes in the front, making my life a little easier. We follow up. Invar, you can always come back and watch this later. I'm recording this part, okay? FYI. 1/2 u to the 5 over 5 plus c. Okay, how did I do that so quickly? Remember, this is a power rule, n plus 1 over n plus 1. That's why 4 plus 1 is 5 as exponent and also as a fraction. Rewriting this is 1 over 10 plus c. U to the 5th power. U we said was sine squared of, not sine squared, I'm sorry, sine to the 5th of 2x. Yep, and that's the answer. So looking at these problems again, all these basic integrals, we're just using a lot of times power rule. If I pick number 7, 7 looks a little harder, but it's not actually any different. This is really 2 separate integrals minus integral of x squared dx. And we mentioned the integral of a constant 1. If I write it as on the side integral of 1 x to the 0, 0 plus 1 is still 1, 0 plus 1 is still 1. So I'm giving myself back an x. 2 plus 1 over 2 plus 1 is 3. That's a minus sign. X cubed over 3 plus c. Number 8. Oh no. You could do you could do u substitution, or you can multiply it out. This is integral of 4x squared plus 4x plus 1 dx. If you want, you can take your time. Plus 1, 2x plus 1. Take your time. 2x times 2x is 4x squared. 2x times 1. 1 times 2x, 1 times 1. And then it's 3 separate problems. 4, 2 plus 1 is 3 over 3. 1 plus 1 is 2 over 2 plus x plus c. The negative one, number 9. We can write this as integral of x to the negative 2 exponent. And this becomes power rule again. Negative 2 plus 1, negative 2 plus 1. Power rule works in many different occasions. The only time it doesn't work is on number 10. So x to the negative 1 over negative 1 plus c. Rewriting this, negative 1 over x plus c. So I'm going to put this up. I want you guys to make sure you guys can do all these problems yourself. Do them quickly. Now, number 10 is a new rule that we've covered elsewhere. And we're just reviewing integrals. And the rule goes right up here. The integral of 1 over u du is natural log absolute value of u plus c. So you just stick it in a natural log. This identity is natural log absolute value of t plus c. And this is from the derivative. The derivative of natural log, and then right there in the space out below, natural log of t is 1 over t. That's the derivative. On number 11, there's a 2. Fine, rewrite it. 2 integral du over u. That's back to our identity. Natural log of absolute, natural log of u plus c. Number 12 is like number 9. Number 13, we talked about this before, separating a fraction. Integral of x squared over x plus 4 over x dx. That's x plus 4 over x dx. Now this is a combination. This guy here, it's like this problem here. And this is just pyro. Second one is just pyro. Why do we not do that natural log from 10 or 9? Good question. Here is the reason why we even have to do natural log. So let me go ahead and bring down a place to write this. This will be our last thing for the day. Sorry, running kind of long. Okay. Here's the rule. We said the integral of x squared dx, something like this, just add 1, plus 1, 2 plus 1, right? So this would be x cubed over 3 plus c. We can double check that by taking the derivative. The derivative, bring down the exponent. The 3x minus 1 becomes 2 over 3. Hey, that gives us back the x squared where we wanted to start off with. So why is it that we need 1 over x dx? Why do we need a special rule? It's because if I rewrite this as x to the negative 1 power, like a power, just like what we did for the other problems, if this was on the side integral of 1 over x squared dx, you could rewrite this as the integral of x to the negative 2 power dx. And if we did the power rule, plus 1 over negative 2 plus 1, we would still get a number that makes sense. X to the negative 1 over negative 1 plus c, which is negative 1 over x plus c, right? Because negative x will mean you're on the bottom. But why doesn't it work for this guy here? Well, go ahead and add the plus 1. Negative 1 plus 1 over negative 1 plus 1. You end up making a crucial mistake that we learned not to do in Algebra 1. It's the divide by 0. This is, if I rewrite this, x to the 0 over 0. Now what the hell is that? That is not possible. So the people who designed calculus, or Isaac Newton, whatever, he realized that this doesn't make any sense. You can't do that. So it turns out, even if we graph it, this is the graph of 1 over x. From pre-calc, you should remember the graph looks like this, right? And it turns out that when I go backwards from that graph, it turns out that's the natural log of x. And it's absolute value because it's positive one side and negative on the other side. And logs, if you remember, natural logs cannot be negative. You can't do this, it doesn't exist. That's how we need an absolute value sign. Okay, so that's why we don't do this. All bad. Instead, 1 over x is the integral dx is the natural log of x. Good question. So go ahead and work on these questions. I did do a bunch of them already. I want you guys to do them again to make sure you guys can do them quickly. This worksheet, if you're good at integrals, it's only going to take like 10 minutes. But since you guys are learning, it will take you a little longer. If you guys have any questions, next time I see you guys, the class isn't meeting on Friday because the district has said that's going to be a PD day for everyone. So all the teachers should not be meeting with classes that day, and we should be doing district PD. Normally I'm not going to meet on, I think you guys, it looked like the poll looked like most people wanted C days. I'm going to actually stop recording now.